From the microbes in our soil and cells of the human body,
You're making it sound like we've found a cure for cancer.
to exploring the furthest reaches of outer space and the secrets of our deepest oceans.
We're going on a deep dive.
We continue to celebrate Irish science.
This week on 10 Things to Know About, we're looking at the complexities of human memory. From advances in research around living with dementia to our susceptibility to fake news and false memories.
Oh, I so didn't get this right.
The human brain consists of billions of cells called neurons, and despite huge advances in our knowledge of how the connections between neurons enable us to form memories, we're still only at the very tip of understanding one of life's great mysteries.
If your brain worked like a digital video recorder, it could store 2.5 petabytes of information. That's enough to hold 3 million hours of TV. But of course, human memories don't work like a video camera. Our brains influence what we perceive and what we remember, making our memories of events and situations malleable, and in some cases, susceptible to corruption.
I'm meeting UCC psychologist Gillian Murphy to investigate some of the murky mysteries of human memory.
Gillian, I normally have a better idea of when I'm about to do an experiment, but you want me to be completely ignorant.
Yep, I'm telling you absolutely nothing. This is our driving simulation lab. You can see it's a full car. It has kind of gears and the accelerator, the brakes, the whole lot, and it's surrounded by screens, so it's very immersive. So you're just going to hop in, you're just going to drive, and we'll ask you some questions about something afterwards.
Okay, I already have my driving license, so you can't take that off me. Seatbelt on, and just don't knock anyone down on national television, and keep to the speed limits. God, I'm really nervous. I've never paid so much attention to driving ever. And because I know it's something to do with memory, I'm just going, there's a man wearing a purple jumper. There's a man cycling a bike. Don't knock down that child walking on the footpath. Sorry, this is just nerve-wracking. Overtaken by a very fast SUV. There's Cheryl Cole. There's a big red car. Oh.
Okay, you can come to a stop. There's been a crash, and you are the only witness.
Oh, right. No pressure, Kathriona. You've just witnessed a crash.
Okay, I hope you've recovered from your near car
I had a
accident.
cup of tea with a lot of spoons of sugar in it. I feel fine now.
Okay, some of the work that we do here in UCC, we look to understand people's eyewitness memories. So how well you can understand and remember an event after it's happened. Can you remember what you saw?
Yeah, I just saw an SUV going into the side of a car at a crossroads.
Okay, the Jeep came up behind you and then it overtook you. And if you were to estimate how long the Jeep was behind you before it overtook you, like 30 seconds, 40 seconds, 50
I didn't
seconds?
see him. I wasn't looking in my rearview mirror.
Okay, and did you see the stop sign at the intersection?
I didn't.
Do you think that there was one?
Well, obviously there was a stop sign on one of them because there was a crossroads, so I don't know. I actually couldn't tell you.
Yeah, you can't picture a stop sign anywhere.
I know there was one, but I'm not sure who it was for.
Yeah.
I'm useless.
Okay. So what we know about memory from all of our research is that you see one coherent picture. You see, there was a full picture, you saw this, this, and this. You didn't see any black holes of it. You didn't see anything missing.
Yeah.
And so you can't remember something that's missing. You can't remember something that's full of holes. And so you have to create a coherent picture. And the really interesting thing that we find is that often we fill in those gaps with information that was not in the scene.
Okay.
So one of the best sources for information for kind of reconstructing that image for yourself is things that I'm telling you. And you mightn't even realize that I am telling you some of these things. So you actually did pretty well. You were pretty resistant. So,
Strong.
So you didn't see the Jeep at all. Yeah. But the initial question, when I said to you, how long was the Jeep behind you before it overtook you? We've done some studies and we say, for example, like 30 seconds, 40 seconds, 50 seconds to one condition. And to another condition, we say, for example, like 5 seconds, 10 seconds, 15 seconds. And what you'll get is these drastically different means. It's kind of called anchoring. So I've given you an anchor. I've said around here, and you won't move too far away from that anchor. One of the other questions, what was really interesting when I asked you about the stop sign, what I said to you was, did you see the stop sign at the intersection? If I say, did you see the stop sign, you're twice as likely to say yes than if I said a stop sign.
Okay.
And it's so simple. And there was no stop sign.
There was none?
There was no stop sign. You initially said no, and then the longer
And then you
we
just
talked about
changed
it,
my mind for me. Oh, for God's
and it was
sake.
very powerful because all I asked you to do was just imagine it. Through that kind of method of just asking people, like, can you imagine what that would be like? You start to picture it. And the next time I ask you about it, you picture the picture that you created and you forget
and
that.
then the Jeep went through the stop sign. Oh my God, it was a disaster.
Exactly, but you forget that you actually constructed that
Yes.
image. You think it was real.
As part of her ongoing memory research, Gillian recently carried out an intriguing study after the Repeal the 8th referendum. At the end of a polarised campaign, she quizzed voters on their memory of different news events, but also included some events that were fictional, fake news essentially. She found that yes voters were more likely to falsely remember a scandal about the no campaign, and no voters were more likely to falsely remember a scandal about the yes campaign.
We also found that people believed the stories that more closely aligned with their own beliefs. Some people wrote things like, this was the day I decided to vote yes when I heard this, or this was the day I decided to vote
so
no.
emphatic about it.
Yeah.
I mean, I think I have a good memory, but I'd be less confident in my memories. Like, I'd be more open to being wrong.
That's kind of my motto, I think, that you should always be open to being wrong. Really, the good news is, and I suppose the take home is that we are right like 99% of the time. The key thing is to just have a bit of humility about your memory. I think it's okay to just say, maybe I don't remember. Maybe I'm not going to have a huge argument with my friend about whether or not...
Maybe your husband was right.
Maybe he was, maybe he wasn't. Who knows?
So as Kathriona discovered, our attention plays a crucial role in memory encoding and memory recall. I'm here in UCD to meet Assistant Professor Ciara Greene, who's researching the links between memory and attentional capacity.
You could think about a memory as being almost like a Lego tower that a child is building, okay? So every little brick in that tower is a part of the memory. I think when most people think about their memories, they tend to imagine it as being either like a video that you can kind of rewind back and forth and you see the same things in the same order every time, or else they picture it as being like almost like a box you're putting in a suitcase, and you're putting the suitcase in the attic, and when you want to remember it, you take it back out and it's, you know, exactly where you left it. It's not like that at all. Actually, our memories are stored all around our brain, distributed around in different pieces. And every time we remember something, we reconstruct that memory from scratch. So we actually build it back up.
So does it mean that we can't necessarily always trust our memories if every time that we're recalling them, we're actually building it up and could be slightly different every time?
Absolutely. And that's what's actually sometimes a little bit scary about this. If you have a memory that you retrieve a lot, so you've broken that memory down, stored it around your brain, and then built it back up again, over and over. Every time you do that, there's a potential for there to be maybe a little error in that reconstruction. So you've built it a little bit differently. So the more times you do that, the greater the chances are that there might be some kind of flaws in that memory.
You're upsetting me now because my first memory is something that I've really treasured, but actually I probably made it up.
How old were you?
3.
Okay, well, it might be real, but anything before about 3, probably not real.
Part of Ciara's research is investigating the factors that might make our memories less reliable and more susceptible to suggestibility and misinformation.
What we found is that the factor that really comes into play here is attention. Attention acts like a filter, that we select some items and we discard others, okay? How many items we can let through that filter depends on our attentional capacity. If that attentional capacity is quite small, then we're only able to pay attention to a small number of items. If that capacity is larger, we're able to take in more items. The important thing is that for everybody, while the size of that capacity might vary, for everybody it is limited. It's very much a limited resource.
Are some people just better at paying attention to the broader scene than other people? Is that something that kind of differs from individual to individual?
Well, that's actually something we're looking into at the moment. There is quite a lot of variation. And one thing that we're looking at here is something called working memory capacity. And this is an idea of essentially how much of those cognitive resources you have available to play with. And we're saying that if people, we're theorizing that people who have more of these resources available might be able to take in all of this information and might be able to deal with all the misinformation that's coming in and separate it out separate fact from fiction.
To help demonstrate, Ciara is going to assess my working memory capacity through a simple attention span test, where she'll ask me to carry out 2 simultaneous but independent tasks.
So the 2 tasks I'm going to get you to do is you're going to be asked to memorize a series of letters that you see on the screen. And while you're holding those in memory, you're also going to do some simple maths problems.
Right. Is it important to work quickly?
It's important that you're both quick and accurate.
Okay. It's very important that I get the maths problems correct.
Yeah.
It is anyway, because it would be embarrassing if I wasn't. 2 4s are 8, minus 6 is 2. So that's true, and it's T, okay? 1 minus 0 is 1. TP. 1 plus 1 is 2. TPL. 1 minus 1 is 0. TPL. TPLY. Oh no. 8 2s are 16 and 7. Okay. 23. TPLYJ. Oh no. Oh my god. Sorry. What? 15. Oh no. Or I have no idea. Oh, no. Okay. TPL.
If you don't know, you can put a blank.
Blank. YJ or? Oh, I so didn't get this right. 4 out of 7. Oh my god.
Okay, no, it's okay. It was a really hard one to start with.
L-Y.
Ciara gets me to do the test a few times so she can properly assess my results, but thankfully I'm starting to get the hang of it.
It's a 7 out of 7.
Okay, great.
Am I done?
Then we'll leave it there. Yeah.
Okay.
Brilliant. Well done. Okay.
That wasn't easy.
You did really, really well. You did well above average in terms of the number of letters you were able to recall. And you only made 2 maths errors in the whole thing.
Right.
So that was actually really, really excellent. So I would take that to mean that you have excellent working memory capacity. And we haven't yet completed our research, but if what we think is going to be the case is the case, that would mean that you might be less susceptible to false memory effects than someone who had lower score.
Now, at the beginning of this test, though, I was getting things wrong and I didn't remember the sequence of letters, and it was really frustrating, and I felt like I was being bombarded. So I needed to figure out a way that I could remember it. Is that kind of cheating?
No, that's just coming up with a cognitive strategy, and people do that all the time.
Okay.
And in fact, that's nearly part of the test, that can you do that? Can you come up with a way of compartmentalising the information?
I imagine there's so much that we have yet to learn about memory and the brain.
Absolutely. I mean, I've heard somebody say once that if our brains were simple enough for us to understand them, we'd be too simple to understand them. So there's still a huge amount to learn, and every day we're discovering new questions. That is kind of the aim, really. For every question that you answer, you come up with 10 new questions to ask.
Transplanting memories from one brain to another has made many a Hollywood movie. But this year, scientists have moved a step closer to turning science fiction into total recall. To do this, forget Schwarzenegger and enter the humble marine snail. Having 3 excellent characteristics, being slow, small, and simple, snails were the ideal animal for a team of scientists from Los Angeles to dabble in the murky world of memories. An initial group of snails was given a small electric shock, sensitizing them so that when prodded, they curled up defensively for much longer than they normally would. Then some RNA, the lesser known but equally as important partner of DNA, was carefully extracted from these snails. This was then injected into a new set of just as slow-moving but previously unshocked snails. Amazingly, these recipient snails also became sensitized, curling up when prodded in a prolonged manner and suggesting that the memory of the electric shocks had been transplanted. Now, I know what you're thinking. This is pretty far out stuff, and you're not wrong. But for memory researchers, it showed that essential parts of the memory trace, or the engram, could potentially be stored in brain cells rather than the gaps between brain cells. And for those who study the science of memories, this opens up an exciting new future. And of course, past. See you next time.
The World Health Organization has confirmed dementia is one of the greatest societal challenges of the 21st century. An estimated 50 million people live with dementia worldwide, and that figure is set to increase dramatically over the coming years.
But these figures only tell one part of the story. Kathriona was diagnosed with Alzheimer's disease when she was in her early 50s.
It's important to realise that this is an invisible disability, and those of us who are younger or at any stage of the disease, we need help, and there are things that are challenging. I fall down the stairs unless I remember to hold on to the banisters. I have to focus on every single thing I do. Some of them are silly and I just laugh about them. You know, you can get into the shower and I get out and I think, God, I don't feel very clean. I don't think I used any shower gel or shampoo. And for me, I have to laugh at those things or I'd crack up altogether. Living alone, I really would. But things more serious like, you know, I took out the grill recently and took what was on the grill off with my bare fingers. I didn't stop to think to use a tongs or a fork. So I never know. It's like walking through a minefield that I'll go to do something and suddenly it's like, I don't know what I was doing. I don't remember why I was doing it. It's exhausting. But I can either sit down and feel very sorry for myself and very hard done by and focus on what's coming down the line, which is horrible. It's not nice. There's none of it nice. Or I can live today and right now and enjoy what I'm doing. I've met you this morning, and so, you know, they're what I choose each day to do.
It seems that you help yourself manage as well with a great sense of humour. You manage to cope quite well by looking upon some of the things that happen to you with the sense of humour.
I do cry. Sadness isn't going to kill anybody, but I prefer the laughter bit. And I have friends, and friends would know me now, and they're great. You know, I've had people who haven't given me a hug since I've told them of my diagnosis. I'm not sure whether they know that it's not contagious. I've had people walk the other way from me in shops. That's very hard to deal with when you're trying to deal with the diagnosis. And equally so, I have friends who just are incredible, and they take pot shots at me, and they will, you know, say, we can do this tonight because you won't remember tomorrow. You know, it's I suppose, a coping mechanism. It's something I do. Laughter is good. It's good. Better laughter than a pill.
Dementia is not a single disease. It's an umbrella term that describes a group of different conditions affecting the brain. Alzheimer's disease is the most common form of dementia and accounts for 60 to 70% of all cases. In dementia, cells in the brain lose the ability to communicate with each other and eventually die. This loss of nerve cells or neurons cause the symptoms of dementia, such as decline in memory and other thinking skills.
Clearly, dementia is a growing issue in our modern society, and billions are being spent globally in the search for a cure. But what if we could prevent it from developing in the first place?
As part of an exciting new international study, researchers are looking to identify the early signs of Alzheimer's disease, years before memory loss and confusion develop. Craig Ritchie is the project lead of the PREVENT study.
So the PREVENT project came about probably about 5 or 6 years ago. And I was working in London at the time, in my clinic there, and I actually saw a gentleman who's in his mid-50s. Both his parents had Alzheimer's dementia, and he came down to see me, and we did a whole thorough assessment about what his risks were and what he could do about it. And at the end of this assessment, we sat back and he said to me, so Craig, what is my actual risk and what can I actually do about it? And I said to him, look, to be absolutely honest, I don't know, and I don't know. Because I couldn't give him a percentage probability, and I couldn't say specifically for you this is what you should do. And he said, we're going to have to do something about it. And that was the genesis, that was the starting point of the PREVENT project. You know, we really understand the diseases that lead to dementia start in midlife, maybe as early as your 30s or your 40s. So to prevent dementia, what we had to do was really understand the disease, how it expressed itself, what the risk factors were for it, etc., in that group of people. So the people who are actually involved in this project, the participants who come in, the research participants who come in, they've been from all walks of life. They get a really, really thorough assessment of their brain health, if you like. And then the great thing is we follow these people up over time. Because ultimately what we want to do is go back to the beginning and be able to predict in somebody at baseline, that guy who came to see me in the clinic at London, exactly what his risk is and exactly what's causing it.
The PREVENT project began in Dublin 6 months ago. It involves studying a variety of people in midlife, some who have a family history of Alzheimer's disease and some who don't. I'm meeting Brian Lawlor in Trinity College Dublin, who is leading the Irish side of the study.
Talk to me about the PREVENT study. What are you looking at and what are you hoping to find?
What we're trying to find is early markers that tell us that these people are very much at risk of developing dementia. Now, this may sound like science fiction, but in fact, if you take a condition like diabetes, we have a marker for diabetes, a blood test, high blood sugar. And if we take those people at risk of developing diabetes and give them an intervention like exercise and diet, we can actually delay the onset of diabetes in these individuals by 3 to 5 years. And we think that we can do the same thing with dementia.
Mark Lingard lives in Cork and is a keen amateur Thai boxer. He's also a participant on the PREVENT study.
I got a personal interest because my mum's partner's in the very early stages of dementia. But I think I probably would have done it anyway because it's so prevalent. Once I applied to the project and got accepted, then I was given a date to come into St James and we gave blood and urine and saliva samples. And then I did a set of cognitive tests, memory tests, which, as far as I understand it, is to set a baseline, which will then repeat these tests every 2 years and see how things have altered from the previous section that you've done. And then I went back and gave the spinal fluid one, which was purely voluntary. I mean, all the way along, there was no pressure put on to give the spinal fluid in. It's got a sort of terrible reputation in lumbar puncture. You don't very often get the chance to be involved in something as groundbreaking, something as earth-moving. It would make a change to millions and millions of people's lives all over the world. And to think that you may have played a tiny little part in that, it gives you a good feeling.
This is a really good example of citizen science. People are aware of the problem, they really want to help, and they really see research in the area of prevention as a way forward.
It's a massive responsibility because I think we can do this. I think we can, change the game substantially. But we've got to keep going as researchers, working with our participants to really get that information and knowledge out there. I'm hugely optimistic. It's going to be a very different future.
That's our 10 things to know about memory. Next week, we're investigating ways to turn waste into energy.